Project by Adam Killeen and Mickey Smith was an attempt to perform transfer learning on the YOLOv3 network in order to identify human beings from a bird's eye view from images taken on drones. The project was pitched in collaboration with 3View, a company that does search and rescue. So we finally selected a network to use. We shopped around for a bunch of different networks. We looked at AlexNet, ResNet, some of the simpler ones. None of them were able to handle the large images that we needed to use. Some of these images were 2,000 by 2,000, and this parameter kind of funneled us towards selecting the YOLOv3 network. Our goal was to take this YOLOv3 detection system and train only its detection layers on the Okutama action drone dataset, which was taken at Stanford University. There's like 112 layers in YOLO, and we only wanted to train the 3 detection layers and see whether or not it would be able to identify pictures from above. And this data set provided some great bounding boxes of humans in different anatomical positions, and so that's the data set that we used. One major step that we needed to go through was to recreate these annotations, because the bounding boxes were in a different format than what is used with the YOLOv3 network. So here's the COCO data set that the network is pre-trained on. You have images and labels, training and validation sets. Here's the list of images that they have. And then what we transferred onto is this Okutama data set. We had to put everything in the same structure. Here are the images. So here's just an example image. And there are no people in that one. Okay. And then the labels, I had to create a parser to undo this file and change the format of all these numbers, because they use very different indexes and like pixel annotations for where bounding boxes were, and those were put into text files that look like so. And that mirrors the COCO data set's annotations. Here's a .cfg file that essentially dictates the shape of the network and which layers are convolutional and which are not. We've never used one of these before, but it was integrated into the darknet network, so that's why we used it. Here's the actual test and train PI files. Train takes in an argument transfer, so it knows whether or not it is training the entire network or just the 3 YOLO layers. Here's a .data file that essentially tells the network where the images are located that it's training on and validating on. Here we are training over 10 epochs on 500 images from the Okutama dataset. Again, training those 3 layers, 1, 2, and 3, where the gradient's actually being tracked. And this is going to take forever, so I will pause and resume. Here's one of 10 epochs during the training. The 500 images are contained within 31 batches. The XY is loss with respect to the location of the center of the bounding box. WH is the width and height of the bounding box. Conf is the confidence loss, and CLS is the classification loss. These are all totaled into the total column. As you can see, over the 31 batches, the total loss does decrease significantly. The time, it takes about a minute per batch. So of these 31, it takes about 30 minutes to get through a single epoch. Training on the Okutama dataset will produce best as the weights that you can then input to detect on an image. YOLOv3 are the pre-trained weights. So this shows how well the network performs before and after training. Using the YOLOv3 pre-trained weights on the COCO dataset, it can identify this human picture with high confidence. When you give it this bird's eye view picture, it identifies some humans. It labels them as birds, but that's okay. After the training, unfortunately, we cannot identify anything. So it doesn't see the people, which is okay. We don't really care about these types of images, but when you look from above, it still does not see these humans. So there's definitely more work to be done using transfer learning. We do think that there's new methods that give us a higher probability of success. Specifically, the You Only Look Twice network is a future direction that we would take to improve upon this. But we learned a lot in this process. Mickey and I would like to thank you for the whole course. This is my last homework assignment I'll ever do as an undergraduate student. So boiler up, and thank you for everything.